Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving another problem on linked list. So let's see what is the problem. So the problem is called find the middle of linked list. Let's say you are given a linked list 1, 2, 3, 4, 5, right? Then in this linked list, how many nodes are there? 5 nodes, right? Now you have to find what is the middle node here. Right here you can see this is 3, right? So why? Because this is contain even numbers, odd number of node, right? So when there is even number of node, like here you can see there are 6 node, right? 1, 2, 3, 4, 5, 6. Now here what will be middle? There will be two elements, right? 3 and 4. Those two will be middle. But here in this problem we have to return the right one, right? The right one. So if there are two middle nodes, return the second middle. The second middle. That's why even there are two middle 3 and 4, we have to return 4 here. Now how we can do? So let's see. So the brute force approach could be, let's say we have first linked list. Let's say, yeah. So let's say 1, then it is connected to 2, then it is connected to 3, then 4, then 5, right? So one approach, this is one thing. So what will be the middle node? Middle node will be this, right? This will be our middle node. How we can find what will be the brute force approach? First thing. So brute force approach could be, let's say, first you calculate the length of the linked list. So length of the linked list, okay? Length. So let's say you go through each node, then you'll take a count variable or something else. Then let's say length is 5. Okay, you got the length. Then what we'll do, we'll divided this by 2. Okay, divided this by 2. Then whatever integer you will got, that's next node. So let's say you got second node as middle node, right? So that's next. So second node of next, that will be our middle node. Let's take any other example where node is even. So 1, 2, then 3, then let's say 4, then let's say 5 and 6. So here let's find out. So what is the length? Length is 6, right? Then we'll divide this by 2. Okay, what will be the result? Result will be 3, right? So means third node. So third node's next will be this, right? So that will be our middle node. That is the brute force approach. But there is another solution, right? There is another approach that we can follow. That is called slow first approach. Let's see what it is. So that is basically two pointers approach. So two pointers approach. So here what we'll do, we'll take two pointer. One is called slow pointer. You can name whatever you want. Slow pointer. One is called first. Okay, first pointer. Then what we'll do, so when we traverse a linked list, go through each node, there we'll take a current node, right? We'll take a pointer as current node. Then every time we iterate, what we'll do? We'll do current equals to current dot next. Current dot next, right? So that means we every time, so current moves by one step, right? Current moves by one step. Current will be current dot next. So here, how? So this pointer is same, but the rule is when we move our this slow pointer will be moved by one step. So slow will be slow dot next. Okay, and this fast pointer, so as name suggests, that is first, right? So that will move by two step. So sorry, this is not slow. First will be moved by first dot next dot next. That means, let's take this example. Okay, 1, 2, 3, 4, 5. So if let's say take first, this is a slow pointer. Okay, so every time slow will be here, so will be incremented by one step, right? So will be moved by one. So first slow will be here, then slow will be slow dot next, right? That will be slow. Then this will be slow, then this will be slow, then this will be our slow pointer. That's how slow pointer moves. But how first pointer will move? So initially first pointer will be the head node, so that will be first. Now first will be moved by f equals to f dot next dot next. That means in each time f will be moved by two step, means first initial would be here, then first will be moved by this. So this, right? So that will be first. Then in the next step, first will be here. First will be here. Now let's see how we can solve this problem using this two-pointer approach. So let's write it again. Okay, let's try it 1, then 2, then 3, then 4, then 5. Okay, let's take this. And this is equals to none. Okay, so let's take two pointers. First, this is, let's take slow pointer. Okay, this is S, slow pointer. And let's take another pointer as first pointer. Okay, so let's take this is as fast. Okay, so in next step, what will be the slow? Slow will be slow dot next, right? So yeah, slow will be slow dot next. So in the next step, slow will be slow dot next here. Okay, Control Z. Let's say slow will be here. Okay, then first, what is the condition for first? First will be fast dot next dot next. Okay, first will be, so this was first dot next is this, then next dot next means this. So first will be here. So let's take another, yeah, first will be here. Okay, right, slow is here, first is here. Okay, this is step number 1. Then in the next step, what we'll do, in the next iteration, what we'll do, again we'll move our slow pointer by 1. So we'll move our slow to here, slow to here. Okay, slow will be here. Then again we'll be move our first pointer. First was initially here, then first dot next is 4, first dot next is 5. Okay, so this will be our first pointer. Okay, done. Now the first has comes to the end element, right? So here if we move the first pointer further, we can move the slow pointer itself, but we can't move the first pointer again because this is none, right? This is none. So that's where we can end up, right? Now you can see whatever the slow pointer is there, so where the slow pointer stops, this is our resultant answer. So here exactly 3 is the resultant answer, this is the middle node. So whatever slow is stopped, where slow is stopped, that is our middle node. Let's try with even number of node. Let's say 1, then 2, let's then 3, then let's say 4, 5, then let's say 6. Okay, this is none. So let's do for this also. So initially slow will be here, okay, and first will be here. So in the next iteration, what we'll do, we'll move our slow pointer by 1 step. Okay, so slow will be here, slow will be slow dot next, and this first will be first dot next dot next. That means this one. That means this one will be first pointer. Okay. Now, is the first dot next is none? No, right? So then move again. So we move our slow pointer by 1 step. Uh, by 1 step. Just a second. Yeah. So slow will be here. Then move our first pointer by 2. Okay. First will be here. Okay. Slow is here. First is here. Then is the first dot next is none? None? No, right? Then we'll move again. So first make slow to here. And again more fast to none, right? Now the first node is none, so we can't move this node further, right? So here we will stop, where we will stop the execution. Now whatever the slow pointer, that will be our result. So here you can see 4 is our middle node. So here also where slow pointer stopped, that is our result, right? So that's how we can do using this slow and first pointer technique. Let's see. Let's write the code for this. First, we'll take two pointer. Slow equals to, that will be initially head, and first, let's take pointer first as initially it will be also head. Then we'll do the operation until while uh, first is not null, right? First not equals to none, and first dot next not equals to none. Okay, first dot next not equals to none. Okay, this is the condition. Then what we'll do, we'll move our slow pointer by just one. Okay, slow dot next, and we'll move our first pointer first equals to first dot next, right? And outside of while loop, what we'll have to return whatever the slow pointer, that will be our middle node. Let's run it. Yeah, it is accepted. Let's submit it. Yeah, it is accepted. So this is very easy. We can do this using this slow first pointer approach. I hope now you have understood the problem.